So, on numerical methods, we want to talk about the numerical methods of integration. So, the first method, we want to talk about the mid-ordinate. The mid-ordinate rule. Now, to find the area under a curve with the mid-ordinate rule, a curve is divided into parts referred to as the strips. So let's say, for instance, this is our Cartesian coordinate system. This is our Cartesian coordinate system. Then we want to estimate the area under that curve. Are you together? So we want to estimate the area under that curve, maybe from the x value here 0 and up to the last x value here, maybe up to the last x value there 5. And this is our curve y, which is a function of x. When I say y is a function of x, it means y is in terms of x. It can be y is 2x squared plus 3x. Well, that means y is a function of x. So we want to see how do we get the area under this curve using the mid-ordinate rule, okay? So to get the area under this curve using mid-ordinate rule, we will divide this curve into the given number of parts, and those parts are referred to as the strips, isn't it? So that the moment we are going to get the area of the region under the whole of this curve, and the x-axis there, then we will just be summing the area of the strips, isn't it? Because the total area will be the area of the sum of the areas of the strips. So there we have. Let's say, for instance, we want to divide it into 4 parts. Are you seeing that? So when you want to divide this into 4 parts, these strips, they must be of equal intervals. We said the parts are referred to as the strips. They must be of equal intervals. We said if interval is the width, isn't it? Interval is the width of each and every strip. So these are the intervals, meaning these intervals must be equal. So you see, here you are starting from 0 to 5, meaning the whole of this interval is 5 minus 0. The whole of this length, this range, isn't it? From here up to here, you get as a width of, what is that range? 5 minus 0, meaning it is? Meaning this 5 must be divided into 4 equal parts, or 4 equal intervals, isn't it? So 4 equal intervals, meaning each interval is going to take the whole length divided by into 4 equal parts, isn't it? Each part is going to take 1.25, meaning here is 1.25, 1.25, 1.25, 1.25, 1.25, 1.25. Now these parts are always denoted by the intervals, not parts, I mean the intervals, the width of the parts, because these parts are the strips, isn't it? Now, these intervals, or the widths of the strips, are denoted by h. Are we together? So, you see, it means that any time you want to find the area under a curve, you must know the number of strips you are dealing with. And for you to know the number of strips you are dealing with, it means each and every strip has its own interval, isn't it? So it means when you are told you are dividing into 4 equal intervals, so you are dividing just in 4 intervals because all those intervals are equal, isn't it? So if you are told you are going to divide, taking a mid-ordinate rule with 4 intervals, meaning they are telling you to divide into 4 parts, isn't it? And each part has the same interval, isn't it? So one thing you can deduce from there is that the number of parts is equals to number of parts, and the parts are the strips, isn't it? Is equals to what? The number of intervals, because each strip has its own interval. The strip is the part, isn't it? Each strip has its own interval. So the first thing, before you go to the rule you want to use, whether you want to use the mid-ordinate rule, whether you want to use the trapezoidal rule, whether you want to use the Simpsons rule, the first thing before you even talk about the rule is how to get the size of the intervals. Are you seeing that? That is before you go to any rule you want to use. Whether you are told to use mid-ordinate or what, one thing you have to know, how many intervals do I have, and what is going to be the width of each and every interval, the size of each and every interval, isn't it? That is the first step, isn't it? Now the next step is now to identify which rule am I using to get the area. In this case, I've divided into four equal parts. I can say this is part A, this is part B, this is part C, this is part D. So that the moment I'm now going to look for the area is just going to be the sum of the areas of each and every strip, isn't it? So this ABCD are the strips, the parts, isn't it? So when I'm getting the area under this curve, it is just the sum of the area of those parts or strips. Are we together? Now, after that, the next thing we now need to know, which rule are we dealing with? So in our case, which rule do we want to deal with? The mid-ordinate rule. So in the mid-ordinate rule, what happens? In the mid-ordinate rule, the word mid-ordinate. So ordinates, you know, this is a Cartesian coordinate system. It is the XY coordinate system, the X coordinate and the Y coordinate, isn't it? And you can see the X coordinates are just giving you the intervals. It is now the length of these strips are now given by the Y coordinates. Are you seeing that? The Y coordinates. So in mid-ordinate rule, mid means those coordinates in the middle. Are we together? So it means when you want to approximate the area under this part A, you use the ordinate in the middle. The ordinate in the middle. So here in the middle, if this is the ordinate in the middle, if here is 0, the middle point of this interval is the ordinate in the middle, isn't it? So that when you join it, you see it will pass. It will pass like that, isn't it? Then the middle point of this interval is the ordinate in the middle, isn't it? So that is the X ordinate, and the Y, the corresponding Y coordinate is here to the end of the curve, isn't it? Are you seeing the mid-ordinate rule? It uses the ordinate in the middle. Then here, the midpoint of this interval gives you the ordinate in the middle, isn't it? So that when you join to get the corresponding Y ordinate of that strip, it is that, isn't it? When you come here, this interval, that is the ordinate in the middle. So that point, that is the X ordinate, then you get its corresponding Y ordinate of that part is there. So you see, you found the middle ordinate. So I want you to stick to noting the first ordinate. Always start with a Y note. Most books will start with Y1. The reason why I'm insisting you start with Y note, it will be very easier to master the formulas with the Y note when we go to Simpson's rule. Okay? You will see, because each and every formula for you to be a good mathematician, you must always have a criteria of mastering a formula, isn't it? So when you start with the Y note, it will be very easy to master those given formulas. So the first middle ordinate is the Y note, then it means the next middle ordinate is, then the last middle ordinate is. So what are we saying in mid-ordinate rule? Each and every strip has its own only one ordinate, isn't it? So you see in mid-ordinate rule, the number of strips are the same as the number of ordinates. Are you seeing these are the critical things you have to master? Because somebody will come and tell you, using mid-ordinate rule with 7 ordinates, find the area or evaluate this given integral. If that integral is for determining the area under curve, isn't it? So when you're told using mid-ordinate rule with 7 ordinates, but for you to get the area under curve, it is not the ordinates you are interested in. The area under curves are the area of each and every strips, isn't it? So from those 7 ordinates, you have to know how many strips will I get from 7 ordinate in mid-ordinate rule. Are you getting the critical point? You know that in mid-ordinate rule, the number of strips will be the same as the number of ordinates. So the moment they tell you use 7 ordinates, it's like they're telling you to use 7 strips. You divide it into 7 equal parts, into 7 parts with equal intervals, isn't it? Because the parts are not equal, it is their intervals which are the same, isn't it? Are you seeing that? So in mid-ordinate rule, the number of strips are the same as the number of ordinates, which is not going to be the case with other rules. So you see where you need to master this rule. If you go to other rule, you find it is a different relationship, isn't it? So that is the relationship in mid-ordinate rule which matters, isn't it? So the first thing we'll say, you need to know how to get the size of each interval before you even identify the rule, isn't it? Then after that, you need to know how many ordinates do I have in the rule I'm using, isn't it? And these ordinates, how many steps are they do they have in that given rule? So in mid-ordinate rule, we've seen the number of ordinates are the same as the number of steps, but the number of interval will always be the same as the number of steps because each step has its own interval, isn't it? And they are equal, isn't it? In size. Are we together? So after this, when you want to approximate the area, in mid-ordinate rule, the area is approximated with rectangles. So you see, at this point, this is the end of this ordinate. So at the end of that ordinate, you make it form a rectangle like that. So if you make it form a rectangle, it means there's a part which is left out, and there's a part which was outside but introduced inside the rectangle, isn't it? So you see, we are approximating the area. Meaning the part which is left outside is approximately, we are assuming is approximately the same as the part which is added inside. So you see the area we are getting to this rule are approximated areas. So if you come to this next midpoint here, you form the rectangle there, isn't it? So here if you join your rectangles, it will be like this. Are you seeing? Are you seeing how the rectangle looks? So you see this part of the curve is left outside and this part is introduced inside the rectangle. So we are saying the part which is left outside is approximately the same as the part which is introduced inside. So we are approximating the area of a rectangle. Are you seeing what's happening? You go to this next one, the mid-ordinate is here. If you form that rectangle, you have this if you form that rectangle. So here you see the part which is left outside is this part, isn't it? You see it is approximately this part which is added because this part was outside and it is now added in the rectangle, isn't it? So you see it is approximately the area of that part. That rectangle is approximating that area. Yes. Isn't it? You go to this part, you see it is ending at that point, isn't it? So if you form that rectangle, the rectangle will be like that, isn't it? That will be the rectangle. So what do you see? There's part which is left outside the rectangle, isn't it? Yes. And there's part which is introduced inside the rectangle. So we are saying it is approximate. Meaning the approximate area of this rectangle is the approximate area under that curve, isn't it? Yes. Have you seen that? So that is the mid-ordinate rule. And how do you get the area of a rectangle? It is length times width. And you can see the width is the edge and the length is the y-ordinate, isn't it? Because the length from here up to here is the same as the length from here up here. So it is just length times width. Have you seen that? Isn't it? Because this length in the middle here is the same as this length here, isn't it? If you come to y1, this length in the middle is the same as this length, so it is length times width. You get the area of that rectangle. Are you seeing? And the area of that rectangle is approximating the area of that strip. Are we together? Yes. So from here you now see the area of parts. If you start with the area of part, it is length which is edge times the length which is y naught times the width edge, isn't it? Yes. Then what is the area of part B? It is the length which is y1 times width which is edge, isn't it? So that is edge y1. Then the area of part C, it is the length which is y2 times the width which is edge, isn't it? So you have edge y, then the area of part D, it is the length which is y3 times the width which is edge, isn't it? So you get edge y. So now what is now the area under that curve? What is now the area? So it is the sum of these areas of each and every strip, isn't it? So the area will be the area of part A plus the area of part B plus the area of part C plus the area of part A plus part B plus part C plus part D, isn't it? So what do we have? Area of part A is h, area of part B is h, area of part C is h, and area of part D is h. So from there you can see h is the common factor, isn't it? So if you factorize h outside, you get the area is h into y0 plus y1 plus y2 plus y3. So this is how to get the area with the mid-ordinate. The mid-ordinate rule. Mid-ordinate rule is just the interval times the sum of the ordinates. The sum of that? The sum of the ordinates. Have you seen how mid-ordinate rule is easier? For you to get the area under curve, it is just the interval or the width of each strip times the sum of those given ordinates. So it means when you are told to determine the area using mid-ordinate rule with 7 intervals. So if it is with 7 intervals, then it means we are going to have 7 strips. 7 intervals means 7 strips, isn't it? And in mid-ordinate rule, each and every strip has only 1 ordinate in the middle, isn't it? So it means it is also going to be the same as 7 ordinates, isn't it? So this y0 up to y1 will move up to y6 because we start counting from y0, isn't it? See, from y0 to y6 gives you a total of 7 ordinates. Are we together? So that is how to determine the area and a curve with the mid-ordinate rule. Is that well understood?
Yes.
Very good. Now we want to see the next rule, the trapezoidal rule. How do we estimate the area and a curve with the trapezoidal rule? We've seen the mid-ordinate rule is very simple. It is just h times the sum of the ordinates. And you are seeing those ordinates are there, the ordinates in the middle. Are we together? Good. So let us go to the trapezoidal rule, and we see what now happens with the trapezoidal rule. We want to see what happens in case of the trapezoidal rule. Trapezoidal rule. Now, just like a case in mid-ordinate rule, before even you identify the rule you are dealing with, you have to know how many strips do you want to use in that given rule, isn't it? So just like a case of mid-ordinate rule, if I have this is my Cartesian coordinate system, the xy plane, that is the y-axis, the x-axis, and this is the curve. I want to approximate the area up to that point, isn't it? So if I want to start from here and head here, then this is my curve. I want to approximate the area y to be a function of x in that case. You know, all the time it will not be, let's say, let me put some smooth curve. Not all the time it will be y a function. Sometimes you have the theta for the trigonometric functions in that one, isn't it? Some smooth curve, just like that. And I want to approximate the area, maybe from 0 to certain value here, isn't it? Maybe I can even say 4, just for the sake of explanation, okay? Now I want the area under this curve. Let's say this curve is y a function of x. So if maybe I want to approximate the area of this curve with, let's say maybe I want to divide it into 6 intervals. You know those intervals must be equal, isn't it? So when I talk of 6 intervals, I'm talking of 6 strips, because each strip or part has its own interval, isn't it? So if I want to divide it into 6 intervals, I must have 6 strips. So let us divide it into 6 intervals. When I divide it into 6 intervals, it means each and every interval here is giving you a strip, isn't it? So 6 intervals, number of strips will always be the same as the number of intervals, because each interval, the ones we were denoting by h, each interval is for each part, and those parts are the strips, isn't it? So the number of strips are always the same as the number of intervals. Now what is differing is the number of ordinates. That is what we want to see, isn't it? Now in mid-ordinate rule, we saw that is a case. The ordinates were in the middle of each and every part. That's why the number of ordinates was the same as number of strips in mid-ordinate rule, isn't it? But now in trapezoidal rule, we are not now approximating with the ordinates in the middle. We are now approximating with these ordinates in the end of each and every part. Are you seeing that? Meaning, each part now, we are now approximating from here to here. Now this is our y0, the next ordinate is this, isn't it? This is now our y1, the next ordinate is this, that is our y. The next ordinate, y ordinate is here, that is our y3. The next ordinate here is y. The next ordinate here is y5. And the next ordinate here is y6. Are you seeing that? Now look at the trapezoidal rule. The mid-ordinate rule was using the ordinates in the middle. In the middle, meaning the number of ordinates were going to be equal to the number of steps. But now this one is using the ordinates at the end of each and every step, isn't it? So if you see, the number of ordinates are more than the number of steps in trapezoidal rule. Have you seen that? Yes. Very different with the mid-ordinate rule. Because if you count these ordinates, 1, 2, 3, 4, 5, 6, 7. Meaning when you are dealing with the 6 parts, we'll give you 7 ordinates in mid-ordinate rule. So it means the number of steps is always the number of ordinates minus 1. Meaning when you are told to use trapezoidal rule with 6 ordinates. So a trapezoidal rule with 6 ordinates will imply how many parts? 5 parts. Because the number of ordinates are more than the number of steps by 1, isn't it? So it means if you remove 1 from the number of ordinates, it will be the same as number of steps, isn't it? So if you are told to use a trapezoidal rule with 6 strips, already you've been given the number of steps on the spot. You know the number of steps you have, isn't it? Or 6 intervals. The number of intervals maintained to the number of parts will be the same as the number of parts, isn't it? So those are the key points you need to master when you are dealing with this rule. So trapezoidal rule is from the trapezium form. It is using the trapeziums, isn't it? The mid-ordinate rule is so we were approximating the area with the rectangles, isn't it? Now we are approximating here the rule with the trapeziums, the area with the trapeziums. So this point here and this, you now join it with a straight line to form a trapeza like that. So you can see when it is trapezia, the area of this trapezia is approximately the area under that curve, isn't it? The next part here, you put there and there, and you join with a straight line to form a trapezia like that. So you can see the area of this trapezia is approximately the area under that curve. There is not much left outside, isn't it? Have you seen that? Then if you go to this next part, this point and this point, if you join to form a trapezia like that, the area of that trapezia will be approximately the area under that part, isn't it? You do the same for each and every part, this point and this point, you join to form a trapezia, then the area of that trapezia will be approximately the area under that curve. Then this section again, you join to form a trapezia, the area of that trapezia will be approximately the area under that curve. That part, isn't it? Here again, you join the 2 dots to form a trapezia, the area of that trapezia will be approximately the area of that strip, isn't it? So if the strips, you denote them by A, B, C, D. If this is strip A, strip B, strip C, strip D, strip E, strip F. Then what is the area of strip A? See, the area of a trapeza is always given by half H A plus B. Where, in our case, you can see this is our H, isn't it? Then these are the A and B for the trapeza, isn't it? So it means our A and B for this part, this trapeza is Y0 and Y1, isn't it? And our H remains there. It is like this trapeza has been turned upside down, isn't it? So it means the area is a half H A plus B, Y1 plus Y0 for that part. For that part A, isn't it? You go to the next part. For this part B, what is the area? It is a half H into A plus B, Y1 plus Y2, isn't it? Y1 plus Y2 plus Y2. Then the area of the next part C, will be a half H Y2 plus Y2 plus Y3. Then the area of part D will be a half H, then part D we have Y3 plus Y3 plus Y4. Then the area of part E is a half H, then we have Y4 plus Y5. Then the area of the last part F, will be a half H, Y5 plus Y5 plus Y6. So it means the area under this curve will be approximately the sum of the area of each and every trapezoidal or trapezoidal strips, isn't it? Are we together? So here, if you sum the area of each and every trapezium here will be approximately the area under that curve. So the area, according to the trapezoidal rule, will be the sum of the areas of the parts or strips and gives you the total area. If you sum the area of these strips, each and every strip will give you the area under that curve for the interval from 0 to 4 in that case, isn't it? Meaning for you to get h in here, you know the whole range is from 0 to 4. 4 minus 0, you get the whole of that range to be 4, isn't it? So 4 must be, for you to get h, that 4 must be divided into how many equal parts? Into 6 equal parts, isn't it? Because the whole length from 0 to 4 here is a length of 4, isn't it? That length of 4 must be divided into 6 equal parts, meaning 4 divided by 6 parts, isn't it? 4 divided by, so that you get the h, isn't it? Are we together? Good. So, if you add all these areas, what do you see? If you are adding, you can see a half h is a common factor. So you are going to factorize a half h outside, isn't it? Then inside you are going to remain with y0 plus y1, then plus y1 plus y2, then y2 plus y3, then y3 plus y4, then plus y4 plus y5, then plus y5 plus y6. So if you look at this, the area by trapezoidal rule, what do you note there? The ends, you can see the ends, y0 and y6 are only appearing once, while the rest are appearing twice, the middles, isn't it? So that means the area with the trapezoidal rule is a half h, then into sum of the ends. Sum of the ends plus twice sum of the middles. Because y1 plus y1 is 2y1. y2 plus y2 is 2y2, isn't it? y3 plus y3 is 2y3. y4 plus y4 is 2y1. y5 plus y5 is 2y5. So it means it is the sum of the ends. Then plus twice the sum of the middles, because these middle ones are appearing twice, each of them, isn't it? Are you seeing that? So the trapezoidal rule is the ends, the sum of the ends plus twice the sum of the middle coordinates, isn't it? Like that. So that is that trapezoidal rule. That is how to determine the area with the trapezoidal rule. Are we together? Yes, you can see y1 plus y1 is 2y, y1, 2, y2, 2, y3. So 2 is a common factor you factorize outside, isn't it? So the area with the trapezoidal rule is a half h y0 plus y6, which is sum of the ends plus twice sum of the middles, isn't it? Now, we now want to see how to deal with the Simpsons rule. We have to master these 3 rules before we start doing examples, isn't it? Now, look at this. Can we start from what we got in mid-ordinate, how did the area come about, and what we found in trapezoidal, how has the area come about, and what are we going to get in Simpsons? So what are we going to get in Simpsons? We've seen how to determine the area and the curve with the mid-ordinate rule. So what have we seen in mid-ordinate rule? In mid-ordinate rule, the first thing we've seen is that the number of strips is equal to number of intervals. Strips are the parts, and those are the same as the number of ordinates, because each part has one ordinate in the middle, isn't it? And we've seen that the area is given by h into the sum of the ordinates. Ordinates are from y0, y1, y2, plus up to yn, the last ordinate, isn't it? Then we've now seen, again, that is in mid-ordinate rule. We've also seen in trapezoidal rule. In trapezoidal rule, this was mid-ordinate rule. We've seen the number of parts, strips, will always be the same as the number of intervals, because each interval is for each part, isn't it? And it is the same as number of ordinates minus
1.
number of ordinates minus 1. So if you have 7 ordinates, it means 6 stripes, isn't it? 7 minus 1, isn't it? Because it uses trapeziums to approximate the area. So in that case, we've demonstrated that. Then we've seen the area is given by this is h, this is now a half h, then the sum of the ends, isn't it? So the ends is going to be y naught and yn, the end. The last one, we don't know what n is, which parts were there, or how many ordinates were there, isn't it? Then plus twice the middle parts, isn't it? So twice y1, y2 plus, the last middle part will be yn minus 1 if yn is the last, isn't it? Now, in Simpson's rule, I don't want to derive Simpson's rules, that's why I want to show you the criteria of mastering them, okay? Simpson's rule. Now see how to mastering getting an area under curve. Before you get an area under curve, in Simpson's rule, the number of strips everywhere will always be the same as the number of intervals, isn't it? Because each interval is for each strip, isn't it? Each strip must have its own interval, which is the same as number of ordinates minus 1. Just like a case in trapezoidal. Are we together? Okay? Though we did it is using 3 ordinates and 1 and it's utilized some case of visualization. It is ordinates minus 1, just the case like it is an expansion of the trapezoidal rule. Let me use that simple fact, okay? It is an expansion of the trapezoidal rule. So the number of the relationship of the trapezoidal rule is the same as this. So the area, because the area, if this was a half h, the area here you will find to be a third. So in mid-ordinate rule, we are starting from h, Simpson rule is a half h, trapezoidal rule is a half h, then Simpson rule is now a third h. Then sum of the ends. Are you seeing that? Sum of the ends. Y naught plus, then plus twice. Now it is plus twice sum of evens. We are saying evens because we are starting with y naught. Are we together? If you start with y1, it will be sum of all. So we will confuse the formulas. That's why I'm insisting always start with the y naught. Whether you see some books starting with y1, just start with y naught because y naught will be very easy to master this formula. Okay? So twice the sum of the evens. y2 plus y4 is even, isn't it? Plus y n minus 2 is even. So then plus 4 times the sum of the odds. y1 plus y3 plus yn minus 1 is odd, isn't it? Are you seeing? So the logarithm which will help you master is this. You just say 2 times 2 is 4, 4 times 1 is 4. So 4 is balanced. You will know how not to confuse the formula, you see? But if you come and confuse and you say it twice, odds and 4 times even, you'll see 4 times 2 is 8, 2 times 1 is 2. So it is not balancing at 4. So you see your formula is wrong because you have an logarithm of mastering a formula. Are you getting what I'm implying? Are you seeing that? So the logarithm of mastering a formula here, you will easily tell which one is twice. Is it the evens or the odds? If you multiply evens by 2 times 2, you get 4. If you multiply the odds by 4 times 1, you get 4. So that is balancing. Why is it balancing? Because you started with y naught. Are you seeing that? When you started with y1, it will not be very easy for you to master that formula with a trait, isn't it? You see, in mathematics, the only thing you always need to know is how to master a formula, is how to devise a means of mastering a formula, because the formulas can be derived. But now when you want to use the formula, will you be deriving the formula when you want to use it? No, you will not, isn't it? Meaning you must have a means of mastering a formula. Are we together there? So you can see that's the reason why I started with the mid-ordinate rule, so that we have seen the means. In mid-ordinate rule, it is h, then trapezoidal rule is a half h, then Simpson rule is a third h. Then we've seen Simpson rule is an extension of the trapezoidal rule. If trapezoidal rule, the number of steps is ordinates minus 1, Simpson rule, the same number of steps is ordinates minus 1. And the trapezoidal rule, here was a half h, here we have a third h. The sum of the ends remains the way it was, isn't it? Then now here in twice sum of the middles, now here it is now twice sum of the evens only. Are you seeing that? Then it is plus 4 times the sum of the odds. And that is only working if you start with y, why not? If you start with y1, you will have interfered, you will have introduced your wrong formulas which are no longer obeying our logarithm we were using, the means we were using, isn't it? Are we together? So it means when you are going to start with y1, it means you are going to devise a formula. And when you are devising a new formula, you must also have a new means of mastering it. And that means you are now complicating things which we made simple, isn't it? Are we together? So just start with y, why not? Okay? Good. So that is the end of the mid-ordinate, the numerical methods of integration, mid-ordinate, trapezoidal, and the Simpsons rule. So we want to see an example in each case on how to use these rules. Are we together? Let us see an example.